So how many people have learned the unit circle before, like in high school or something? Okay, that's good. Now you're going to have to memorize it. There's a video I told you about last week that'll help you learn how to memorize it. I'm going to do a couple of things tonight too that'll get you started memorizing that. So to begin with, what we're going to look at is a unit circle just means the radius is 1. That's why we call it the unit circle. So first of all, what we're going to do is we're going to fill in these values. Okay, you had your quiz, you got your quiz back, so either you knew these or you didn't. I was trying to get people to memorize a lot of stuff as fast as is possible. So I'm going to go ahead and write these things down because we need to utilize this to get the unit circle. Okay? So what we're going to do is everywhere we see an R in these definitions, what we're going to do is replace it with 1, and the unit circle simplifies things a little bit. So that means the sign is now going to be y over 1. Okay, so it's just y now. So in a unit circle, the sign is the y value. You don't even have to look at y over r because r is 1 anyway. Okay, the cosine is x over r, so we would just say x over 1, therefore that's x. So that's kind of a big deal. Once we get this unit circle, you'll be able to figure out the sine and cosine very easily just by looking at x and y. The tangent doesn't simplify. It's still y over x. There's no r in that. Same thing with the cotangent. That's still over x over y. Nothing simplifies. And then from here, it's all the same. The cosecant's the reciprocal of the sine, so that's 1 over y. And then the secant is the reciprocal of the cosine, so that's 1 over x. So what you want to kind of look at, and if you haven't done this before, it actually keeps you from having to do the right triangles anymore. So the key thing is this is what simplifies. When we look at a unit circle, you don't have to look at y over r, you just look at y. When you look at a cosine, you don't have to look at x over r, you just look at x. Everything else is essentially the same. Okay, does that make sense? Okay, and it's just because if r is 1, that simplifies that. That's why we call that the unit circle. Okay, a couple other observations that you want to write down. In a unit circle, a cosine is the x value. You'll see what I mean shortly. The sine is the y value. Okay, then remember we've learned this identity. That's the Pythagorean identity. So actually it's real easy to show why this is the case now. So basically, this is what you end up having on this then. So first of all, we said in a unit circle, and we're going to put that 1 right there. In a unit circle, that's y. The sine is y. In a unit circle, the cosine is x. Okay, so what we end up getting is y squared plus x squared equals 1. And we already know that, right? You know that x squared plus y squared equals r squared. So that's kind of where that comes from. Once you learn the unit circle, you'll make a little bit better connection. So that is really just saying x squared plus y squared equals 1, where the radius is 1. Does that make sense? Okay. So basically, I'm just replacing that with y, cosine with x, because that's the way they work in a unit circle. That's what you want to get in mind. Okay. Okay, here is the unit circle. So what we're going to do is, I think I've probably got a unit circle on your handout, maybe on the next page, but you don't have one in color like mine. I like mine better, so I just put mine up there. Okay, what I'm going to do is I'm going to show you what this means, and you're going to have to memorize that. To a student who's never done that before, it looks intimidating. I got to memorize all those points. Yeah, you do, but it's not hard. I'll try to prove that to you tonight. Okay, so what I'm going to do is I'm going to show you where these points come from, okay? And they basically, notice they have a square root of 3 and a square root of 2. They probably come from triangles. What do you think? Okay? Because what you have is a 30-degree angle and a 45, so you can translate these into triangles, okay? So let me show you how you get this point right here, okay? In case you forget, it's easy to come up with. So what I want you to do is just draw a 30-degree angle in quadrant 1. Like we've been doing, we're just going to draw this in standard position. And then what we're going to do is make a triangle out of it. Okay, so we're going to go straight down to the x-axis. How do the sides go on a 30, 60 right triangle? You had that on your quiz. 1, 2, square root of 3, right? Okay, so the 1 actually goes there. The square root of 3 goes there, and the 2 goes there. That's what you've learned so far. Okay, Well, it turns out on this is we're trying to make a unit circle out of this. All right, so remember, we have a circle going around that triangle right there. So when you have a triangle, you can either multiply or divide every side by the same number, and you don't change the angle. So if I want the 2 to turn into a 1, what do? I divide by 2. So you're going to divide everything by 2, and now it's going to pop that point. That's what I want you to see and understand. So let's do that then. So I'm just going to say, let's divide that by 2, divide that by 2, divide that by 2, okay? And when I do that, see, I've got this point. And this point, if you think about the point on the circle, this is an x value, right? That just means you're going over and up. So that's x, that's y. Look at the point that we have. Voila. Square root of 3 over 2, 1/2. That's where it comes from, is from that triangle. It's basically just turning that into a unit circle by dividing by 2. Does that make sense? Okay. All right. So you don't have to know where that comes from. It is helpful, though, to kind of see a few connections on this. Okay, next thing we're going to do is we're going to look at this point here. I'm going to do one more point, and then the rest of them are all the same. Okay, so we're going to do the 45 degree. Okay, so what I'd like you to do on this is just draw a 45 degree angle. Okay, so we're in quadrant 1. And then what we're going to do is look at the 45 right triangle on this one. Okay, so again, I'm going to go straight down to the x-axis. How do the sides go on this triangle? 1, 1, square root of 2. With the 1s being there and the square root of 2 being the radius. Okay, same idea. We want to turn this into a unit circle. So what do you need to do to that square root of 2 to turn it into 1? Divide by the square root of 2, right? And you divide everything by square root of 2. And then a little bit of arithmetic, and then you'll get that point on the unit circle. So I'm just going to do this all the way around. Okay, and of course that's now going to give you 1. And then these things are going to rationalize the denominators. Okay, so if we rationalize denominator, you'll end up having square root of 2 over 2 there. And same thing here. If you do that, you'll have square root of 2 over 2 there. Okay, so what that means is this point this is an x value, so you're going over that distance and up that distance. So that point is going to be root 2 over 2 comma root 2 over 2. Yes?
So sorry, why are you dividing by 2 and then why are you dividing by root 2? You're trying to find...
Because I want this to be a unit circle.
Sure.
And in a unit circle, the radius is 1. So if I divide that by itself, it's going to turn that into a 1. And I have to do the same thing to all parts of the triangle, otherwise I'm changing the angles. Okay, because if you divide or multiply every side by the same thing, the angles stay the same. Okay, that's how that works. Okay. So anyway, what I want you guys to see is this point would be root 2 over 2, comma root 2 over 2. If you look at your unit circle, that's what we got. Okay, so that's where it comes from. All right. So what we're going to do with this unit circle is it's going to simplify our ability to find trig functions. Okay, that's kind of the ultimate goal here. Okay, so what I'm going to do first of all, before I do anything with this, I'm going to show you how to memorize this very quickly. Now, I have a video on Canvas that you can watch if you need to review this, okay? So here's how you remember this. The first thing that you do, and by the way, you'll have next Monday at the beginning of class, you'll have a quiz. You got 1 week to memorize this thing, okay? So start now, okay? Here's how you do this. First of all, you should start with these points. I'm going to do this pretty quickly. And if you don't get it, you can watch the video. Remember, R is 1, right? So what would this point right here be? 1, 0. You're moving over 1 because R is 1. Okay, how about this point up here? What's that? You're going up 1, so it's 0, 1. Okay, how about this point here? You're going to the left 1, so what's that? Negative 1, 0. And then this one, you're going down 1, so what's that? Okay, don't memorize it, just reason it out, okay, because R is how far over you're going. Okay, now I'm going to show you, what I'm going to do is I'm going to show you how quickly and easily it is to get those points right there, okay, just to get those points. So notice that these things have a pattern to it. Okay, the X gets bigger this way, right? X gets bigger. Look at that, 1, 2, 3, see? Y gets bigger this way. 1, 2, 3. Okay, that's all you do is just count in a logical way. So what you can learn how to do is you can do this. This is a real simple way to do that. And once you get these 3 points, you'll have it made. So what I'm going to do is I'm just going to say, okay, that's 1, that's 2, that's 3 like that. Okay, it's going from left to right like that. Now what you're going to notice, if you just remember that they all have an over 2, okay, and the 2 and 3 have a square root on it, then you got it made. So what you can do is you can divide everything by 2, and then just put a square root in the numerator, and then you've got the x value of each point. So this would be 1/2. This would be square root of 2 over 2. And then this one would be square root of 3 over 2, like that. Okay, does that make sense? That's just a little trick that helps you learn that fast. All you got to do is count 1, 2, 3. Okay, divide by 2. Square root of the numerator, then you got it. Okay, that's the x value. Yes?
Why'd you put a square root over the 1/2 instead of 1? When it's 1.
Well, what you're doing is, the trick I'm showing you is, you always divide by 2, because everything's going to have an over 2 in it. Okay? And then just remember to take the square root. What I'm doing is I'm trying to show you a way to remember it and develop it real fast. Okay? Because once you start working with this, you will get those down, because you're going to do it so often in the class. So, and I didn't, square root of 1's 1, so I didn't put it on there for that reason. Okay? Now, what happens is this, the y's get bigger this way. Okay, so what I'm going to do on this is kind of go like this. When I get the y values, I'm going to go 1, 2, 3 like that. Okay, and then you can do this all in your head. Everything has an over 2 in it. Okay, and then it's just going to go square root of 3, square root of 2, and square root of 1's 1. Then you got it. That's it. Okay, and it's real easy, because if you look at this, it just goes 1, 2, 3 that way, which is logical, and the y's go 1, 2, 3 that way. Does that make sense? Okay? Now, once you get this, how do you get this? There's not hardly any difference. If you move this point over here, what happened? The x turned into a negative, right? Okay, if you move this over here, the x turned into a negative. And if you move this over here, the x turned into a negative also. Okay, so once you have that, then you have that as long as you understand how points work. Okay, look at quadrant 4. What happened? The x didn't change. What changed? Y changed. So negative, 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 and so forth like that. So at a minimum, if you get those 3 points done, the rest of it you can figure out. You see what I mean? Okay, just think of it as 1, 2, 3 that way, 1, 2, 3 that way. You'll remember it. Everything's over 2, and then you got a square root with the 3 and 2. Okay, that's just I'm just teaching you a way to remember it. Yeah.
Do you want us to memorize the radians too?
Yeah, you have to write. We're going to work on that in just a second.
Oh, all right. Sorry.
Okay. Because we're going to count it, and we're going to learn how to count it out. It's actually very easy. Okay. All right. Does that make sense? What I did there?
Yes.
Okay. All right. Keep it simple. You want to be able to get those points real fast. Okay. Okay. Now I'm going to erase this. Now I'm going to do the angles. Okay, so here's how the angles go. All right, now the way that I do this is like this. There's more than one way to do this, but what I'm going to do is I'm going to go around the circle, and I'm going to count out. I'm going to teach you how to count out these angles right here. I'm going by 45-degree increments, and these things have patterns to them too. Okay, but here's how you can do this. Okay, I'm going by 45. All right, so it's going to go like this. All right, all you got to do is count by pi over 4. What you got to remember is 45 degrees is pi over 4. Okay, if you remember that at a minimum, the rest of it works great. Okay, well, that's 0. You obviously got that one, right? Okay, well, this one's pi over 4, right? Then what comes next? 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, okay, you see what I'm doing? 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, all you do is reduce these, and look what happens. Okay, so I've got, what's 2 pi over 4? Isn't that pi over 2 when you reduce it? 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. You reduce. That's it. Okay, you see what I did? Okay. Now what you can do is you can count by 30s if you want to. Now you can count by 30s all the way to the circle if you want to. but I like to kind of get the 45s out of the way and do that. Okay, now we're going to count by 30s. All right, so let me show you how this goes. Okay, so 30 degrees is pi over 6. You either remember that or you figure it out by converting it to radians. Okay, what we do is we just count it out. Again, you guys don't have to write this down, just pay attention. It's just 1 pi over 6, 2 pi over 6, 3 pi over 6, and so forth. See what I'm doing? I'm counting by the numerator, and that's it. And if you go all the way around that circle, I want you to notice what happens on this. So 30 degrees would be here. Okay, what is 2 pi over 6? That's really pi over 3, right? What is 3 pi over 6? Pi over 2, okay? But 4 pi over 6 reduces to 2 pi over 3, okay? 5 pi over 6 is there. What is 6 pi over 6? It's pi. And then you just keep doing that all the way around. That's it. Isn't that easy? Okay? All right, so it's not that hard to memorize this thing. Just figure it out as you go. All you got to know how to do is count. Okay, that's it. All right, and then know the structure of the points, then you got it. Okay? If you didn't catch on to that tonight, then, look at the video, or I've got some blank unit circles on Canvas. It's not a bad idea to print them out and see if you can recreate it. You have till next Monday, because you'll have a quiz next Monday beginning of class. I give you 10 minutes to fill all the points out and all the radian measures, not the degrees, the radians. Okay? All right, that's the idea. Okay, so here's what we do with the unit circle now. Okay, what this actually does is it simplifies our ability to find a trig function at any of these points. Okay, so here's what you're going to do. To start with, we're going to look at the sine of 5 pi over 3. Okay, if you're doing the sine of 5 pi over 3, in a unit circle, all you're doing is looking at the y value only. So what you do is you locate 5 pi over 3. You find where that is, so that's there. What's the y value? It's negative square root of 3 over 2. Problem done. That's how you do it. So if you want to find a sine, all you do is look at the y value. That's it. That's how easy it is. Okay? All right? That takes care of that. Now let's go down. I'm going to go down to this cosine. Okay? So if we do a cosine of negative 5 pi over 4, and again, you can convert that to degrees, but you want to learn how to count these things out. What is pi over 4? It's important to know that. 45, right? So if you just count this like this, that would be negative 1 pi over 4, negative 2 pi over 4, negative 3 pi, negative 4 pi, negative 5 pi. You see what I mean? You can count by pi over 4s, and then on a cosine, what do you look for? You look for the x value, okay? So where you're going to end up on this problem is there. You're going to end up there. So it's the x value. So that means the answer to that problem is negative square root of 2 over 2. Okay, so there's nothing to finding a sine and cosine. You should be able to just boom, boom, like that. For instance, what is the sine of 7 pi over 6? What's the sine? Negative 1/2. What's the cosine of 7 pi over 6? Negative 3 pi over 2. That's it. Sine's y, cosine's x. That's it. So once you get it memorized, you can do sine and cosine very fast. You see what I mean? Okay. Now the rest of them you do have to crunch out a little bit. So let's look at the next one, the secant. Okay. Well, first of all, which trig function is the secant the reciprocal of? The cosine. Okay. So what I would do on this is I would just start by doing the cosine of 3 pi over 4. So look at my unit circle, find 3 pi over 4, and what's the cosine? It's the x value, right? So what do? Flip it upside down, rationalize denominator. So anytime you want to do a secant, you look at the x value and you do a reciprocal. That's how that goes, all right? So the answer to this would go like this then. So the cosine is negative root 2 over 2, therefore, the secant of 3 pi over 4 is just going to be negative 2 over root 2. Then you want to rationalize denominator, okay? So let's do that. Multiply by root 2 over 2, okay? And simplify, so that would be negative 2 root 2 over 2. And then the 2's do cross out. So the answer to that would be negative square root of 2. Okay, so that's what the answer to secant is. Okay, does that make sense? Okay. All right. What if you wanted to find a cosecant? Let me just do this real quick, and you don't necessarily have to write this down. What if I said find the cosecant of 11 pi over 6? How would you do that? I would want you to do it in your head. What's this the reciprocal of? The sine. There's 11 pi over 6. What is the sine of 11 pi over 6? It's the y value. Therefore, what's cosecant? Negative 2. See what I mean? Okay, see how easy it is? Okay, the unit circle is a very powerful tool. Okay, so that's going to give negative 2 over 1 like that. Okay, and the last one, let me do this cotangent. Okay, so we have the cotangent of 3 pi over 4. Now what you have to do on the cotangent and tangent is you have to just go to your definitions. So this is x over y. Okay, so if you go to 3 pi over 4, 3 pi over 4 would be here. So what you do is you just take the x value, which is negative root 2 over 2, and divide that by the y value. Okay, well, what's that going to be in your head? Negative 1. You're dividing by the same number, right? Okay, so you would just get negative 1 if you do that then. Okay, all right, let me show you one other thing. Let's do the tangent of 11 pi over 6. Okay, so the tangent's y over x. So if you what you would do is you would look at 11 pi over 6. Tangent would be y over x. With a little practice, you can learn to do this in your head too. So what you would get is at 11 pi over 6, y would be negative 1/2. Then you would divide by the x value, square root of 3 over 2. You can do this in your head. I'm doing it as a division problem just to remind you of what happens. So you can do the reciprocal. That's how you divide fractions. That crosses out. And then that would leave you with rationalizing the denominator. Okay, so if I do that, square root of 3 over 3 would be negative root 3 over 3. So that's it, okay? So just to kind of reiterate what I just did, because you want to get this down, and the idea is, okay, if you want to find the sine, what do you do? Tell me what you do on the unit circle if you want to find the sine. What do you look at? Y value, okay? So let's just think about 4 pi over 3. The sine of 4 pi over 3 would be negative square root of 3 over 2. Okay? How do you find the cosine? X. The cosine of 4 pi over 3 would be negative 1/2, just like that. How do you find the secant? It's the reciprocal of the cosine. What's the cosine? That. So what's the secant? Negative 2 over 1. How do you find the cosecant? You find the sine and turn it upside down. The sine is this, right? Turn it upside down. How do you find the tangent? You do y over x. So you would have to do that over that. Cotangent, x over y. That's it. Now it's easier. You don't have to draw triangles anymore. So you want to get the unit circle down and be able to get those things figured out real fast. Okay? All right, so everybody with me okay? Okay? Cosines x, sines y. Everything else, just use your regular definitions on. Okay. So the next thing we're going to look at is kind of a review of, because we're going to get into graphing here tonight, is what we mean by even and odd functions. If you had college algebra or pre-calc, you've learned about this before. So what I want to do is kind of show you an example of an odd function and an even function. And these are important things to know when we do trigonometry, because we'll have functions that are odd or even. Okay, so a function's odd if this is the case, and it's even if that's the case. Now, I'm going to show you what that means, because a lot of times students read that definition and they don't know what it's talking about. I would recommend that you write down a note to yourself like this. So here's an example of an odd function. Okay, I'm just going to randomly pick a point like 2, negative 4. Okay, if you have an odd function, then you will also have this point. Odd functions work like this. If x becomes opposite, so does y. Okay, that's what odd functions are. And if you can learn it this way, it'll help you understand it. All an odd function means is when x is opposite, so is y. So I think opposite x gives opposite y. That's how odd functions work. Okay. So if you had an odd function, I guarantee it, those 2 points would be on on the graph. Okay, does that make sense? Both are opposite. Okay, that's how odd functions work. So I sometimes try to get students to just remember this: opposite x, opposite y. That's it. That's how odd functions work. Okay, now even functions work like this. So I'll make up another point. I'm going to say 3 and 5. Okay, even functions are different. What happens is, if you change the 3 to a negative, then the y value stays the same. Okay, so I think of an even function as opposite x gives the same y. Okay, that's how even and odd functions work. Okay, so these things are going to both be on the graph if it's an even function. Does that make sense?
Yeah.
Now see, that's what this statement says. If you change x to negative x, the function stays the same. It's still f of x. This is saying if you change the x to negative, what happens to the function? It becomes the opposite. So it is saying opposite x, opposite function value. This is saying opposite x, same function value. Everybody see what I mean? Okay, that's the best way to reason this out, is to learn it that way, I think. Okay. Okay, now odd functions are symmetric about the origin. I'll give you an example of that in just a minute. And even functions have a symmetry about the y. So what I'm going to do is I'm going to have you do a graph to kind of get us going on this then. So we're going to graph out y is equal to x to the third. This is an odd function, and it's partially because it has an odd exponent. But just because a function has an odd exponent does not mean it's an odd function, by the way. It may be odd, or it could be something else. Okay? So what we're going to do, to keep it simple, we're going to make a table of values. And I'm just going to give you some x values to use. So we're going to use like 0, 1, 2, negative 1, negative 2. And this will also help you figure out the symmetry. So we're going to do this in our head. So we're going to do negative 2 to the third, which is what? Negative 8. Negative times negative times negative is negative, right? What's negative 1 to the third? Negative 1, right? 1 times 1 times 1 is 1, okay? What is 0 to the third? 0. 1 to the third? 1. 2 to the third, 2 times 2 times 2 is 8, like that, okay? So this is an example of how an odd function works. Now I want to see if you guys see this or not. What happened when you have an opposite x? What happened to y? You have an opposite y. Look at this. Opposite x, opposite y. That's how odd functions work, okay? Now let's just draw a graph. Let's kind of plot our points. So I'll put a negative 2 and a 2, and then we'll go up like 8 and down negative 8 like that. So if you plot your points, you would have 0, 0, 1, 1, 2, 8, negative 1, negative 1, and negative 2, negative 8 like that. So if you plot your points, that's what your graph looks like, okay? Now, how is that symmetric? You guys know what that is from your background? We call this origin symmetry, and what that means is this. If something's symmetrical about the origin, it means if you took a point and folded it over the y-axis, and then took that point and folded it over x, it would match another point on the graph. So just imagine this. Move it there, then it's there. See what I mean? You fold over y, then x, or x, then y, and everything matches. So what you typically have in an odd function is you might have things in opposite quadrants because you have opposite x and opposite y. Okay, does that make sense, what I'm talking about by an odd function then? Okay, now when we start looking at trig functions tonight, we're going to look at the sine and cosine. Sine ends up being odd, cosine ends up being even. Okay, so that is what we call symmetric about the origin. Okay, all right, any questions? Okay, give me a sign. I don't know. You got to tell me something. Okay, a thumbs up or something, because I don't know. Okay, sometimes we get into some background issues on these problems a little bit. Okay, so that would be an odd function. And one other thing I want to do on this is also do an even function. I want you to kind of squeeze this in somewhere. Okay, I'll just kind of keep this simple. Let's say that we have y equals x squared. That's a good standard even function to show a student. Okay, So let's see. Let's do a table of values. So we have x and y. And let's use the same numbers. Let's use 0, 1, 2, -1, -2, like that. Okay, now all we're doing is squaring, and you can do this in your head. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. Okay, like that. Now, I want you to see what happens. Okay, so tell me, if x is opposite, what's happening to y? Nothing, okay? Opposite x, same y. See what I mean? Opposite x, same y. That's how even functions work, and that forces you to have some sort of a symmetry. So then if you went through and plotted this, this is a parabola, and this one's going to be symmetric about the y-axis. So this one just looks kind of like this. If you plot out the points, you end up with that, okay? So that's the idea. So for instance, this point's 2, 4. This point is -2, 4. So again, it means if x is opposite, then y stays the same. That's the idea, okay? So that's kind of a classic example of odd and even. Everybody got that okay? Okay? So just kind of, that's how you look at the symmetry of those points on odd and even. It's neither if neither of those symmetries works. Okay, now this stuff that I'm going to show you here probably ends up making more sense to students once they learn how to graph, but the unit circle would also help you on that a little bit. So what I'm going to do is I need to find me a unit circle on here somewhere, and I'm going to cut and paste it real quick because this might be something that would help you make sense of this too. But I'm going to teach you how to remember these identities. Okay, so trig, you're finding out by now that you have a lot of things you have to memorize, right? And you don't blindly memorize these identities, you reason them out as you go. Okay, and again, you'll get this down better once we learn graphing. Okay, so the odd functions are, we're going to look at the sine, cosecant, tangent, and cotangent. They're all odd functions. Okay, so the identity goes like this. What you got to remember is if you have an odd function, okay, I'm just going to give you a quick example on this. If you have opposite x, then you have opposite y. Okay, so the identity goes like this then. What you would say is sine of -x, that's an opposite angle, equals the opposite function value. So do you guys see that the structure of this identity is always the same if you have an odd function? Okay, now I'm going to try to show you something on this and see if this makes any sense to you, just with my unit circle here. Okay, let's say that we have the sine of -30 degrees. According to that identity, that should be negative sine of 30. Okay, let's look at that and see if that's right. Okay, all right, -30 is in what quadrant, class? Quadrant 4, right? Okay, tell me what the sine of the angle is there. We now know unit circle, sine's the y value, right? So that's going to be -1/2. Okay, now look at the sine of 30. The sine of 30 is here. What is it? 1/2. So therefore, you got to do the opposite of that. That's how that works. So when you have an odd function, it works like this. The basic idea, you can tell on this unit circle that a sine's opposite, because look at this. You have 30, you have -30. What's the difference in the y's? They are opposites. That's how it works. And that's how it also works on cosecant, tangent, or cotangent. Yes?
So basically, for the negative, we can just pretend it's outside of parentheses?
Yes. Yeah, the way I think of this is kind of like this point here. Opposite x, opposite y. That's why I'm putting the negative with the sign, because it's the opposite of what the sign is. This is just saying when you take the opposite of an angle, you get the opposite of the y value on a unit circle is what that's saying, okay? So if you kind of look at this now, okay? Look at 2 pi over 3 and look at this. Those angles are reflected over the x-axis. Notice what happens is the y values are opposite, aren't they? So that's why the sine would be an odd function. The tangent works like this. The tangent ends up being kind of going this way. So the tangent would kind of work like this. The tangent's y over x. So notice on this, if you had 30 and -30, wouldn't that just be opposite answer for tangent? Because you have y over x would be positive, right? That's all that matters. And then on this, y over x would be negative, but you would get the same ratio. So the tangent works the same way. Okay, does that make sense what I'm saying? Okay. Now, what we have is we have even functions. So we have two even functions. They are the cosine and they are the secant. Okay. And this goes like this. The identity goes like this. If we have cosine of negative x, that ends up to just be the same value, same y value. That's what that's saying. Okay. Now, here's how the unit circle can help you make sense of this. Okay, let's look at 30 and negative 30. That angle, opposite angle. Okay, that's what I'm doing, is this angle opposite. What is the cosine? The cosine's the x value. What do you notice?
Same.
They are the same. How about 45 and negative 45? Same, see? That's what happens. The cosine's the x value. So the unit circle should show you whether something's even or odd. Opposite angle, same x. Does that make sense? Okay, you want to kind of say these things in words, and that'll help you remember this a little better. Okay, all right. So let's see. Here's one way. If you can just remember cosine and secant are even, then the other ones are odd. There's only two even functions. The other ones are odd. Okay, and once we start graphing and working on this over the next couple of classes, I think will help you with that a little bit more too. Okay, so the next things are mostly just for you to look at because we're not doing graphing yet. But this is an example of, we're going to learn how to graph the sine and cosine tonight a little bit. So this is the sine, the one that's in green. The cosecant is the one that's in blue. Okay, does that look like it's symmetric about the origin? You guys know what I mean by symmetric about origin. Okay, if you fold over y, then x, they match. Okay. One thing that you might write on here if you want to, this point right here, you will learn this. You'll have a point pi over 2 and 1. And then this point right here is negative pi over 2, negative 1. What I'm trying to do is just give you an example showing you why that's an odd function. So you'll find every point on that graph has that same kind of an idea. Okay? All right, that's why it's an odd function. Okay, we're going to learn this probably a little bit in Wednesday's class and a little bit into next Monday. This is what the graph of the tangent looks like. Okay, that is an odd function. So here's one thing you're going to learn eventually with your unit circle. This point right here is pi over 4, 1. This point right here is negative pi over 4 and negative 1. So it's the same idea, opposite x, opposite y. A tangent's an odd function. That's how the graph looks. Okay. All right, cotangent looks like this. Same idea, it's an odd function. A couple of key points, you're going to learn that this point is pi over 4, 1. You get that from the unit circle. And you'll learn this point is negative pi over 4, negative 1. It's exactly the same principle, opposite x, opposite y. That's what odd functions look like. And that's why they have the symmetry that they do. Okay? All right, everybody with me? Don't worry about where the graphs come from. We haven't learned it yet, but we're going to start tonight. Okay, here's the even function. So here's a cosine and a secant. So one of the things you're going to learn about a cosine is you'll have a point pi over 4 square root of 2 over 2. That's coming out of the unit circle. Then you'll also find that you have a point negative pi over 4, but the y value will be the same. Okay, like that. So that's how even functions work. Now, how is that symmetrical? It's not about the origin. What's it symmetrical about? About the y. This is easy to see. It's just if you fold over the y-axis, everything matches perfectly, doesn't it? Okay, that's the way even functions work, is they have that type of symmetry then. Okay? Okay, now what I'm going to do to kind of finish this part up here, it's pretty short here, we want to go through and use even and odd identities to figure this out. And we're now going to use the unit circle too, okay? So one of the things I'm going to do, let me put my unit circle here too so we can kind of refer to that. Because we're going to mostly get away a little bit from the triangles now and kind of begin to get a little bit more into the unit circle. Okay, so first of all, here's what you do. If you want to find the answer to sine of negative 60, you've got to realize it's an odd function. So that means it's equal to the opposite of the sine of 60. It just means if the angles are opposite, the answers are opposite. Okay. Now let's look at our unit circle because we're going to get the answer now in a hurry. Okay. So tell me what the sine of 60 degrees is. You should boom, boom, like that if you've got on. There's 60, what's the sine? The sine's the y value, so it is square root of 3 over 2. Okay, so that means you would end up having negative, the negative comes down. You'd have negative square root of 3 over 2. That's the answer. Unit circle gives it to you in a hurry. Okay, let's look at cosine. Cosine is an even function. So that means that this is going to be equal to the cosine of 135. Don't change the cosine, just change the angle. That means opposite x gives the same y value. Okay, let's find 135. Tell me what the cosine is. It is the x value, correct? Okay, so that's it. That means the answer to this problem would be negative square root of 2 over 2. Okay, cosine's x, sine's y. Okay, so you can do that boom, boom. Okay, all right, but you got to know which functions are odd and which are even. Okay, tangent, that's an odd function. Okay, so what's this equal to? If it's an odd function, it's equal to make the angle opposite and then also make the tangent opposite. That's how odd functions work. Okay, so now what we're going to do is this. We're going to look at pi radians. How do you figure out the tangent? What is the definition of the tangent? Y over x, right? Okay, so what you're going to do is you're going to do y over x, which would be 0 over negative 1. So that would be 0. So that just means that's negative 0. So it's 0. Okay, now if you look at this, the other way you could figure this out, but I'm wanting you to learn how to use the odd even identities. Negative pi is this way, right? So negative pi would be there, just like pi, but the angles are coterminal. So that's the ideal. Okay. Okay, let's see. Next one, cosecant. Cosecant is an odd function. So the way this goes, again, is you always change the angle to the opposite. And if it's an odd function, you put a negative there. Okay, so what we need to do is we need to locate 3 pi over 2. Okay, so which trig function is the cosecant the reciprocal of?
Sine.
The sine. What's the sine of 3 pi over 2? It's the y value. It's negative 1. What's the reciprocal of negative 1? Negative 1. That's how you do that. Okay, so the sine is this. The cosecant's reciprocal of that. So what you would have is you would have this. Okay, when you put this together, the cosecant of 3 pi over 2, that part right there is just going to be, and you can think of it as r over y if you want to. R is 1, so that's negative 1, so you have negative negative 1, so the answer to the problem is 1. Okay, now here's the other way to look at this, because you want to try to make as much sense out of this in different ways as you can. Okay, we've learned that if you graphed negative 3 pi over 2, you're going to go clockwise, right? So if you counted it out, this would be 1 pi over 2, 2 pi over 2, 3 pi over 2. Notice that the sine would be 1, right? And the reciprocal of 1 would be 1. So it works, okay? That's how the idea works. Okay? You guys see what I'm doing? Okay. Right? Now, if you can remember what even and odd functions are, and just remember that there's only 2 even functions, being the cosine and secant, and you got it. Okay, and then you got those identities and you can put them together. Okay. Okay, let me bring my circle down here for a second. Let's do a couple more of these here. Okay, so this one would be the secant is an even function. So that means this is going to be equal to the secant of pi over 6. Okay, that means opposite x, same secant, same value. Okay. Okay, so let's find pi over 6. Okay, what is the secant the reciprocal of? The cosine, right? So what would be the cosine of pi over 6? It's the x value, right? So if the cosine of pi over 6 is root 3 over 2, then that means the secant is just the reciprocal of that. So you'd have that. Okay, rationalize denominator and you got it done. Now rationalizing, if you can do it in your head, I'm fine with that because you sure are going to do that a lot in this class. So the answer is 2 root 3 over 3. That's how you do that. Okay? Right? Everybody got that? Okay? Cotangent is odd function. So let me do the one last one here. If it's an odd function, then it's negative cotangent of the opposite angle like that. Okay, that's how the identity goes. All right, now what you want to do on this one is you want to find 330 So 330 is here. How does a person find the cotangent on a unit circle? You do x over y. You got to know that, okay? So that means that x is square root of 3 over 2. Y is negative 1/2. So you got to divide those two things out. Now there's a little trick that you could do. You can just cross the 2's out, okay? Because what you're really doing is multiplying by the reciprocal. So what you would get is square root of 3 over negative 1. So you would get negative square root of 3, okay? So that means the answer to the cotangent is negative root 3, but then that negative tacks on to give you a final answer of positive square root of 3 like that. So that's how you do that, okay? So the first thing is you've got to know which functions are even and odd, how to use the identity, and how to use the unit circle. That's what you have to do. Okay, there's not a lot of work that you show on your paper, but there's a lot of things that you have to know, some basic knowledge to use the unit circle and get that figured out. Okay, does everybody feel like they understand what I'm talking about? Okay. Okay, now we got one more thing I want to talk about, then we're going to start our graphing here. So periodicity just means this, okay? These angles right here are all coterminal, right? Because they're all 360 apart. So that means if you did the sine of a coterminal angle or any trig function of a coterminal angle, you're always going to get the same answer. That's a guarantee, okay? So what I want to kind of show you how to do, and again, I'm going to put my unit circle here for a second here, is we want to figure out the values of these on a unit circle, okay? Well, basically what you would do on this is 420, you could subtract 360 from it, and if you did that, you would get a 60-degree angle. So what this is going to mean is the cosine of 420 is exactly the same as the cosine of 60. That's it, okay? All right, there's 60 degrees. Tell me what the cosine is. 1/2. The cosine is the x value. Therefore, that problem is done. It's 1/2. Okay, you want to do this without your calculator. You want to look at your unit circle and figure these out. That's your goal, okay? Okay, 21 pi. How in the world are we going to do this? I always test over this. On your test next week, you will see big numbers like 21 pi, 99 pi, 98 pi, okay? It's got a pattern to it. So here's the idea that you want to kind of get established here. Okay, so like this is 0 pi. This is 1 pi, like that, okay? This would be 2 pi. This would be 3 pi. This would be 4 pi. That would be 5 pi, okay? So in other words, this is even pi. This is odd pi. Does that make sense? Okay, because I'm just going 0, 2 pi, 4 pi. I'm counting by 2 pi. So therefore, this is odd pi, okay? So where are you if it's odd pi? You're over here, right? Okay, that's where you are. So you don't have to convert that. Sometimes I'll see students take 21 times 180, change it to degrees, subtract 360 a bunch of times until they figure out where they are. Just remember, you have even and odd pi. That's all that matters, okay? So what this is then, this is really the same thing as the tangent of pi. Okay, the tangent's y over x, so that would therefore be 0 over negative 1. So therefore, the answer to that problem would be 0. Okay, that's how you do it. Okay, everybody clear? Odd pi, even pi. Okay, know it that way. Figure it out. Okay. All right, next one. Let's see. There's a couple of ways to do this. You can change this to a degree if you want to. Or you could even do this if you wanted to. It doesn't matter. I don't care which way you do this. But let me ask this question. Is 9 pi over 4 bigger than 2 pi or smaller? Bigger. It's bigger because 8 pi over 4 would be 2 pi, right? So what you could do is you could subtract 2 pi from that if you wanted to. Or you can convert it to degrees and do that way. So I'm going to get a common denominator of 4. And if I do that, see, I'm going to have 9 pi over 4 minus 8 pi over 4. So what I really am looking at is the sine of pi over 4. That's what matters. Those angles are coterminal. Okay, so what you need to do then is go to the unit circle, look at pi over 4, and if you're catching on to what I'm teaching you tonight, tell me what the sine is. It's the what value? It's the y value, so what is it? Square root of 2 over 2. Problem done. That's it. Okay, so that would be equal to square root of 2 over 2. Sine is the y value. Okay. Okay, the next one, okay, 25 pi over 6 is bigger than 2 pi, right? So one way you could do this is you could take 25 pi over 6, and you could do it this way if you wanted to. Well, you could subtract 4 pi, and the reason I know that is because 24 pi over 6 is really 4 pi, right? And this is one way to reason it out, or you can change the degrees if you want to. So I'm going to subtract 4 pi to figure out where I am. I'm going to find a coterminal angle. So what I do is I just get a common denominator. Okay, so that's going to end up being 25 pi over 6 minus 24 pi over 6, which is pi over 6. So really what we need to work out is the secant of pi over 6. Okay, that's how we do it. Now you want to look at your unit circle and figure that out fast. Okay, what is the secant the reciprocal of? The cosine. What's the cosine of pi over 6? It's the x value. Cosine of pi over 6 is root 3 over 2. Therefore, what's the secant? 2 over root 3. Then you rationalize it. That's what you do. If you would do a secant, you look at the cosine and do the reciprocal. Okay, so that is going to be the reciprocal of the x value. So it's 2 over root 3. And then if you rationalize the denominator, you're going to end up getting, that looks like 2 root 3 over 3. That's it. Okay? So the unit circle can make everything a little bit simpler for you. When you get into next week's exam, question 1 on the exam is fill out the unit circle. Okay? All right? And then you'll have lots of problems where you're interpreting the unit circle. Okay? So you have till next Monday to memorize the unit circle. That should be plenty of time. Okay? Okay, now we're going to start into the graphing tonight. And we'll probably kind of do the basics tonight. And then the little bit more advanced stuff next time. Okay? So I'm going to use a unit circle to help you get values on this. So what we're going to do is we're going to graph the sine. And there's a reason why I'm giving you these values, because these values are what matters when you're doing the graph. Okay, all we're going to do is fill in a table of values, and we're going to do the sine. So on a unit circle, what do you look at to find the sine? The y value. Thank you. Okay, very good. So what we're going to do is just go around. I'm going to highlight these y values. Okay, so the sine of 0 would be 0. I'm going to start there. Okay, the sine of pi over 2 would be 1. The sine of pi would be 0. The sine of 3 pi over 2, you'd be down here, that would be negative 1. And then when you get to 2 pi, of course, is all the way around the circle, so then you would be back to 0 like that. Now what that gives you is that gives you what's called 5 key points. It's going to just keep doing that forever, right? Okay. So once you get to 2 pi, when you get to 4 pi, you'll be back to 0 and back to, even pi is always going to be that. Okay. Now if you do this, you'll get the same value. So if you kind of do this, negative pi over 2 is here, right? So that's negative 1. Negative pi is 0. Negative 3 pi over 2 is 1, and so forth. So you can get that from the unit circle. So again, this would be negative pi over 2. So that's negative 1. Negative pi would be 0. And that's negative 3 pi over 2 would be 1. And then that would be 0. Okay, like that. So that's how this goes. We call this a periodic function because things repeat themselves over and over and over again. Okay? Okay, now what we're going to do is create a graph. So one of the things that you guys have to learn how to do is you have to label everything. Okay, so we have to label this in radians. You're never going to ever label these in degrees. You got to do it in radians. So we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, like that. You got to label every one of those. And then you got to label these also. That's negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi like that. And then for the y, go up to 1 and then go down to negative 1 like that. Okay? Now, one of the things you want to catch on how to do is is learn to count these out. See, all this really is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That's it. And then you reduce the fractions. You're counting by 1 pi over 2, 2 pi, 3 pi, 4 pi. That's how the numerator goes. So now what you want to do is you want to plot these points. So I'm going to start like with 0, 0, put a dot there, pi over 2, 1, and so forth. You got pi 0, 3 pi over 2, negative 1, and then 2 pi over 2, or 2 pi and 0 like that. Now this is a curve. It's not like, sometimes I'll see students draw the graphs like this. No, it doesn't look like that. It's not sharp things. It's a nice smooth curve. So draw it in kind of nice and smooth like that. That's the way it's got to look. Okay? Then you just do the rest of the points. And what's going to happen on a sine is it's predictable how it goes. See, if you start here, it's going to be x-intercept low, x-intercept high, low, no, intercept low, back there, high, and so forth. So you're just going to repeat itself over and over again. So this point goes here, then you have that point, and so forth like that. It's periodic. It keeps repeating itself. So that is what the graph of a sine of x is going to look like, is like that. That's it. Okay? All that stuff comes from the y value on the unit circle. That's how you create that. Okay. Everybody follow that okay? Okay. We're going to kind of focus on the basic sine and cosine and a couple of transitions tonight. Okay, so here's a couple things you want to write down. The minimum value of y on this graph is negative 1. The maximum value of y is 1. Okay, the x-intercepts occur at certain places. So we're going to write those things down. What we have is 0, pi, 2 pi. These are the x-intercepts. X-intercepts are just where it crosses the x-axis. Okay, and then that would also be at negative pi and negative 2 pi. Okay, now that's a pattern. Okay, so if you think about this, what do you have? Pi, 2 pi, then what? 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and so forth. It's a pattern that will go on forever. So what we've done is we've graphed what we call 2 cycles of the sine wave, and it has 5 key points. Here's how it goes. 1, 2, 3, 4, 5. That's the beginning, the maximum. We call that the midpoint, the minimum, and then the ending point like that. So it goes 1, 2, 3, 4, 5. That's how a sine goes. And it does that over and over and over again forever. Okay, the y-intercept is here, so you would just have a y-intercept at 0, 0, okay, on that one, okay? Okay, now let me talk about what the amplitude is and kind of introduce you to that concept. What an amplitude is it's half the distance between the max and the minimum, okay? So here's how you would basically figure this out. Okay, the maximum is, what you do is you do 1/2, the maximum is 1, the minimum is negative 1, so you just crunch that out. So if you do that, you would end up having 1/2 of 2, so that would be 1. So the amplitude of the sine is equal to 1. Now here's what it really means. If you look at the graph, this is what an amplitude is. Okay, this is all it is. How far apart is it from there to there? 2, right? What's half of 2? 1. That's what an amplitude is it's half the distance from the minimum to the maximum. So that's 1. Amplitude of 1. Okay, that's what we call that number in a sine wave. Okay, the domain. The domain is all real numbers. Let's see. Let me say this. The period is the width of the shape. That's going to be 2 pi. So the period's 2 pi. So let me explain what I mean by that. Okay, remember you have 5 key points. Count them out. 1, 2, 3, 4, 5. That's a period right there, and that's 2 pi. And every time 2 pi goes by, you're going to cycle through 1, 2, 3, 4, 5 key points. That's what the period is, okay? That's that distance this way. Amplitude's this way, period's that way, okay? All right, now here's how domain goes. Domain is all real numbers. You can do a sine of any angle. There is no place the sine's undefined, no place, okay? If you look at the unit circle, you always have a y value. The sine's the y value always exists, okay? What's the range? Range is this way, so what's it going from where to where this way? negative 1 to 1. Okay, so this is going to be in interval notation, negative 1 to 1 like that. Okay, so that's how you do the basic sine graph, is you just graph the y values around like that. Okay, does everybody understand what I did, how I did that? Okay. Okay. Okay, now we're going to go do the same thing for a cosine tonight. And then we'll probably do one graph or two that have got amplitude changes. Okay, so this is very, very similar to what we did. When you're doing a cosine, what you're doing is you're looking at the x values. So what I'm going to do is in my unit circle, I'm going to go around and just highlight all of the x values going by 90 degrees or pi over 2. And then we're just going to fill them out. So the sine of cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And then 2 pi, you're back to 1. Those are your 5 key points right there. And if you go backwards, if you go negative pi over 2, then you're back to 0. Negative pi, you're back to negative 1. Negative 3 pi over 2 would be back to 0. And all the way around clockwise would be back to 1. So that's how that goes. Now those numbers are all the same, but they're in different places. So when you create your graph, you want to, again, label this like we have in the chart, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so you want to get everything kind of put together. And then over here, you do the negatives the same way. And that's just a matter of plotting your points. And these things have to be labeled, okay? If you're doing a graph for me and they're not labeled, then it doesn't mean anything to me. Okay, the y value just need to have 1 and negative 1. And then if you plot these points, it basically goes like this. You would have 0, 1, pi over 2, 0, pi negative 1, and so forth like that. Now these right here are going to be the 5 key points on a cosine. So you want to kind of think about the cosine starts there, it starts at height, x-intercept minimum, x-intercept like that. So it's 1, 2, 3, 4, 5. So the graph over here is going to do exactly the same thing. Okay, so that means that you're going to be there, 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 and there. So that's how the graph of the cosine goes between negative 2 pi and pi. It looks the same, doesn't it? But there is one slight difference on this, is if you look at the sine you just did, it started at 0, 0. So these things are the same graph, but they kind of have been moved in a certain direction like that, but they have the same shape, okay? So that's how you get that. All this stuff here is the same. The minimum is negative 1. The max is 1. X-intercepts would be pi over 2, 3 pi over 2, and so forth, and negative pi over 2, and negative 3 pi over 2. Now, look and see if there's a pattern that you see on there. Do you see a pattern? This is like 1 pi, 3 pi, what pi? 5 pi over 2, 7 pi over 2, 9 pi over 2. These things always have patterns. So it's odd pi over 2. That's how that goes. That's where your x-intercepts occur on a cosine. And then the y-intercept is this time is 0, 1. So that's your y-intercept. The amplitude is still 1. It's the same as it is on a sine. The period is still 2 pi. The period would be like the distance from there to there. Okay, that's 5 key points going from 0 to 2 pi. So it has the same period. The domain is the same of the sine. It's all real numbers. And the range would be negative 1 to 1 like that then. Okay? All right. So that's how you do the basic graph. Okay? You get the information from the unit circle. Okay. Now, what I want to do on the next page, I want to kind of have time to go through, just kind of introduce you to a little bit of terminology. This is all just vocabulary right now. Okay, so what we're going to look at in the rest of this section is we're going to do some basic transformations like this. So what happens is we're going to look at a number times the sine times a number times x plus or minus a number. Okay, a couple of things that would be good for you to write down is this thing right here. What that does is that's what we call a vertical stretch. You learn a lot about this in college algebra. That's a vertical stretch, and what it means is you just multiply y values by a. Now, in trigonometry, we give that a special name. We call that the amplitude. So that number right there, the a, stands for the amplitude. Okay? All right, what happens on this is, what I want you to write on that omega, what it does is it changes the period. Okay, and what that means is it really is a horizontal stretch or shrink. Right, we'll learn a lot about this in Wednesday night's class. It's a stretch or shrink like that. Okay, what do you think the B does, just from your college algebra background? Like if you had x squared plus 4, what does that do? That's up, down. So that B is just up, down. Okay, like that. Okay, so basically the period is given by the formula. What you have is 2 pi over omega. Okay, that's a formula for that because the period is 2 pi, and if you divide it by omega, that changes the graph, and what it's going to do is either stretch or shrink it this way in the horizontal direction. The vertical translation is going to be B in this problem then, okay? So let's finish up by just kind of getting used to this. Okay, first of all, you have a sign. The amplitude is that number, and it's always positive. You really probably should put the amplitude as absolute value of A, because amplitude is always positive because it's a distance. Okay, amplitude's a positive number. Okay, if you want to do the period, what you do is you do 2 pi divided by the number in front of x. Okay, so you do that. So if you do 2 pi divided by a half, that's really 2 pi times 2. Take the reciprocal, so that would be 4 pi. Okay, period is 2 pi divided by the number in front of x. What's the vertical translation in this problem? 5. Is it up or down? Down, okay, because it's a minus, so you would be basically down 5 on that like that. Okay, so basically the amplitude you see automatically, the vertical translation you see automatically, but finding the period you got to do 2 pi over b. Okay, let's do this number 5, and then that'll be good enough for today. Okay, the amplitude is 5, and just remember that's always a positive number. The period is 2 pi divided by the 1/4. Okay, so the way you got to do that, you divide by a fourth by multiplying by the reciprocal. So what's that? 8 pi. Okay, so that means that this cosine wave gets stretched out that way. Does this have a vertical translation? No, because in order for it to have that, there would have to be a plus number there. So that's, you assume that's 0, so that's how that goes. Okay? Now what we're going to do in Wednesday's class is we're going to learn how to graph things when they have an amplitude change and a period change. And so that's what we'll be working on about the first half of class. And then the second half of class, we'll get into 7-7, where we'll learn how to do the secant and cosecant. Okay, so that will be it for tonight.